I'll start again. Is it okay? No, it is not yet come. Is it visible now?
Yes, sir. The strip on the bottom side, you can click on the height.
Yeah. Okay.
Okay.
Okay. Extremely sorry for this delay. So we were going to revisit the capacitor basics. It's two electrodes separated by a dielectric. These are the formulas. Capacitance is equal to E0 ER into A by D. Q in Coulomb is equal to C by V, C into V, and energy stored in the capacitor is 1 of CV square. How much is the farad? An electron storing capacity of capacitor is measured in unit farad. So 1 farad is approximately the charge with 6.28 into 10 raised to 18 electrons. So store charge, you can see it's just a small bucket. You are trying to fill up the tank. That is a charging unit. It could be a full wave charger, half wave charger. But you keep on pouring, but the discharge you can have continuously the way you want, and you can control, like you control the water flow with the help of a tap. You can always control the discharge with a series resistor. So capacitor technology, if you see, I myself have a background from Philips India Limited, and we are into the manufacturing of passive components. Capacitor manufacturing was one of the mainstream there, and we were manufacturing all the type of capacitors mentioned here, like ceramic, film, electrolytic. Of course, the double layer was not produced in our Pune plant, but we were producing this double layer capacitor in our Klagenfurt factory in France. So if you go for ceramic, there are NPO, X7R and Wi-Fi V. Of course, depending upon the application, if it is in the critical tuning circuit of a radio, then NPO grades are used, and they are also available in the lower picofarad values. Film capacitors, also there are many types like polypropylene, PET, PN, PPS, that is polypropylene, and paper. Paper capacitors are normally, you are all know, they are used into the power factor correction. And electrolytic, you can have the aluminum, tantalum, and niobium. Niobium are used in the costly military equipments. Aluminum capacitors are normally whatever available in the market are single layer capacitor, and the new capacitor that we are going to learn today and its application is double layer capacitor. So if you see the construction of a capacitor, as if there are two capacitors connected in a series. So see the foil, and there is a dielectric in between. Supercapacitors or ultracapacitors can be defined as an energy storage device that stores energy electrostatically by polarizing electrolytic solution. Unlike batteries, no chemical reaction takes place when energy is being stored or discharged into the ultracapacitors. Can go through hundreds and thousands of charging cycles with no degradation. That's the beauty, because you can have number of charge discharge. If you remember a television which was bought by your parents sometime in 70-75, they're still working, and those electronic capacitors are still operational. Ultracapacitors are also known as double layer capacitors or ELDC. So any term that you come across mean the same. Ultracapacitors perform midway between capacitors and electrochemical cells, that is batteries. So they are neither battery nor capacitors, they work in between for the energy storage applications. Fast charge and fast discharge is the capability of the supercapacitor. Unlike battery you cannot charge so fast and discharge so fast as per the need of the application. Highly reversible process and more than 100,000 of cycle. You know, our conventional battery, that is lead acid battery used in your scooter, motorcycle, can withstand only for 500 cycles and then it degrades. And if you remember, few years back there is a wave of electric vehicles in Pune, and most of the companies stop only because of the battery quality, because though they were claiming 500 charge discharge, they were really deteriorating around 300 cycles charge discharge. And within a year span, when you buy a two-wheeler, the batteries were getting damaged and the replacement cost was very high. And that was one of the reason the electrical two-wheeler business stopped in Pune. Of course, it is reopening now, but that time merely it has stopped because of the battery. Lower energy than battery, 10% of the battery energy. So energy density is quite low. That is one of the disadvantage. Greater energy than electrolytic capacitors, because electrolytic capacitors you can see up to 1000 to 2000, maximum 5000, 10,000 farads, microfarads. But now these super capacitors are available in farad value, and it has got an excellent low temperature performance. I will share with you one of my experience in Germany, that how these the capacitors perform. You know, our lead acid batteries don't perform in Leh Ladakh, and all our military vehicles are kept on. They are never switched off because of no energy available for cranking the engine, because the lead acid battery do not perform at lower temperature. So if you go for a supercapacitor technology, there are many technologies today available in the market. One is double layer, what we are discussing, pseudo random, then activated, then in double layer capacitors we have activated carbon and carbon aerogels, carbon nanotubes. Okay, and in pseudo capacitors we have conducting polymers and metal oxide. Then also we have a hybrid capacitor version where we have asymmetric pseudo ELDC and composite pseudo ELDC, rechargeable battery type. So these are the varieties. Of course, some of the technologies will die once the technology is available. Till date, the supercapacitor is not available about 2.5 volt, 2.8 volt to be precise, because that's why you have to use series parallel combination. Technology is growing, and very shortly supercapacitors with 48 volt or 100 volt also will be available. So this is a equivalent circuit of a supercapacitor. Two capacitors are in series, and those resistors, if you see the electrical resistance of the packaging, especially the joints, welding, so they are responsible for the losses or tan delta losses, what precisely the capacitor industry talks. And there are two electrodes separated by a dielectric. That's why the capacitance value is always lower than they have during the manufacturing, because two capacitors are connected in series. Ultra capacitor working by applying voltage to the capacitor, and electric double layer or both electrodes is formed, which has a positive or negative layer of ions depositing on the mirror image of the capacitor opposite electrode. Ultra capacitor stores energy via electrostatic charges, that is ion per radicals, or opposite surface of the electric double layer. The purpose of having separator is to prevent shorting of the electrodes as well as prohibit electron flow. The amount of energy stored in very large compared to a standard capacitor because of the enormous surface area created by the typically porous carbon electrodes and the small charge separation, that is 10 angstroms, created by the dielectric solvent molecule. So this is all a little bit theory, may be boring for you. But if you see the famous Regan plot, where specific power, that is watt per kilogram versus specific energy, watt hour per kg, then you will find supercapacitors in this particular region performing very well. Of course, the specific energy is very low if you see. Like our conventional electrolytic capacitors, because of the 1/2 CV square energy, they can discharge fast, so they can use in a small timer circuits. Compared to that, electric capacitors are better. The best performance is by batteries and of course the fuel cells. So capacitor have got a very low energy density, so it can be applied for only the pulse applications. Tomorrow, if you ask me, can I replace my domestic inverter, which is used for lighting in case of emergency, by supercapacitors? The answer is no, because it will give you few minutes of backup, not hours. Batteries can give you backup in hours. So supercapacitors only can be utilized where you have a pulse energy requirement. So if you see comparison of supercapacitors versus battery, charging time is 1 to 5 hours for a conventional battery. You know, you keep your car charged throughout the night with a charger, but supercapacitors can charge within 30 seconds, which is a beauty, and which really calls for a lot of applications. Discharge time is also 0 to 30 seconds, whereas battery has got a 0.3 hours to 3 hours. So battery has got a good energy storage compared to ultra capacitors. Energy density watt per kg is 5 to 15, whereas battery have 20 to 150. But power density, if you see here, that is watt per kg, is 2000 to 10,000 compared to the battery of 20 to 150. That's why whenever you want to have a punch of energy, especially in the cranking application of cranking application of petrol vehicle, you need a very high inrush current while starting the vehicle. That's why the battery sizes are high. Otherwise, for rest of the application, battery sizes are not that high required. Normally in a car, you have a 32 ampere hour battery, and your Honda Activa or similar, you have a 5 ampere hour battery. So most of the energy is needed for cranking the engine. Charge discharge efficiency is 95 to 98%, which is phenomenal compared to battery 60 to 80. So the top quality battery can have 80%. Recycle life, this is another phenomena. Your vehicle may be scrapped, but the supercapacitors will remain. Compared to the battery, it is just 500 to 1000. 500 charge discharge, you can say. Temperature range, it has got minus 50 to plus 70 degrees, whereas the battery has got minus 10 to 40 degrees. So that's why they don't perform in the Ladakh, where the temperature is minus 30, minus 40. But supercapacitors, they do perform. So this is a comparative picture of battery have high energy density and high discharge time. So if you see pouring water through a mug, you can have a short burst with high water rate. Compared to the conventional battery, you can have some kind of a flow. You cannot discharge the entire jug instantly. So this picture can convince you about the power density capabilities of supercapacitor. Performance, if you see, we are learning this, that's why we will understand the applications further. High power, high energy storage, quick response, fast charge discharge, energy efficiency is 95 to 98%, needs 30% more power than it stores, and long life, 10 to 15 years or more. As a battery backup, excellent battery backup avoids deep discharge of the battery. If you connect supercapacitor with the battery, supercapacitors have a low impedance. So if you connect to any load, the supercapacitor discharges first and avoids the damage of the battery. Because if you allow battery to go in a deep discharge mode, the damage is 100%. The life of the battery reduces drastically. So that's why if you connect supercapacitor with the battery, increases the battery life, and weight is just 1/5 of the battery. Can even replace batteries in low energy applications, especially kickstart two-wheeler. If you see, you need not have the 2.5 ampere hour battery there. You can replace with capacitors because you don't need any cranking there. Cranking you do by kicking the vehicle. Versatile, it is maintenance free, wide temperature range. Okay, well suited for remote non-serviceable locations. And because if you are having any remote rain gauge or remote unit, you can charge it with this solar panel, and it can give you the reliable life throughout the instrument working. It is eco-friendly. There are no pollutants in the manufacturing process. It has got certain disadvantages. As we discussed, please view these disadvantages very closely, because when you are going to apply these capacitors in your electric vehicle application, you have to consider. They have very low energy density, so they cannot be used for a longer burst or longer duration. They cannot. They can be used for a very shorter duration, like cranking a vehicle, because cranking a two-wheeler or four-wheeler, you need energy only for a half a second to 1 second. Not all the energy can be utilized during the discharge. So you cannot completely discharge the supercapacitor. Otherwise, it will create damage, because next charge cycle it will have a very high interest current. They also have high self-discharge as compared to the battery. Because of this mechanical construction of double layer, it has got a self-leakage, you can say, and self-discharge. So it goes down. Though I have experimented and found charge even after a month or so also within acceptable limit. Voltage balancing is required because they are available in lower voltage range. So you have to connect two or three capacitors in series and parallel. So everywhere you have to do the balancing. And there are two types of balancing. One is active balancing and second is passive balancing. So passive balancing can be achieved using resistors across the capacitor. Calculate a little more than the leakage current, and the capacitor will be balanced, and confirm that voltage across each capacitor when connected in series is equal. Otherwise, if capacitor gets higher voltage, it will damage because of the over voltage. So there are certain generic standards available now, because there is huge applications are happening in electric vehicle. So the first application was memory backup, because earlier a battery was used. Now supercapacitors are used as a memory backup. Olden days VCR, if you remember, 1,000 memories, 2,000 memories, it had a battery, lithium battery for that. But now most of the places memory backup supercapacitors are used. Energy storage mainly used for driving motors, require a short time operation. So that is a class 2. Class 3, power, higher power demand for a long time operation. And class 4 is instantaneous power for applications that require high current, peak current rating to several hundreds of amperes with a short operating time. So these are the four classifications mentioned in IEC, that is EN 62391-1, which defines four classes as we saw. Now, though there are application specific standards now, and this IC first standard is IC 62391-2, is fixed electrolytic double layer capacitor used in electric equipment, BDS, electric double layer capacitor for power applications. Second standard is used for in hybrid electric vehicle test methods for electrical characteristics. So this standard has to be applied if you are working on a hybrid design. And third standard, that is 61881-3, is for railway applications, rolling stock equipment, capacitors for power electronics, electric double layer capacitors. This third application we are going to study a little bit with the animation, which will come further. So I think we have covered the basics of supercapacitors, and now we will be viewing the various applications of supercapacitor. So you are all aware now the electric buses Pune we have from BYD, so they have supercapacitors inside for electric power train. They look like exactly similar to the electrolytic capacitor. You can see this diagram or photograph. So they look like exactly electrolytic capacitor. If you remember last year, the Tesla acquired Maxwell, the largest supercapacitor manufacturer of US. Rather, Maxwell was major source for defense. And Tesla, who are pioneer in electric vehicle, have come out with a collaboration, rather acquisition of Maxwell. And this year, the new vehicle that they have launched is having a combination of battery and supercapacitors. So Tesla is wise enough to have acquisition of the top of the world manufacturer of supercapacitor, and that is how the demand. You can also make career in supercapacitor applications. So if you see areas of application, what we are going to view today is for automotive, traction, industry, and consumer electronics. Of course, our focus is more on automotive, where 14 or 42 volt system is used, and high hybrid electric vehicle and electrical subsystems. I mentioned you in my biodata that last year I visited trade shows in Japan and Korea. Idea was to understand what is happening in the leaders of electric vehicles. I saw Koreans are working on electric vehicles, but whereas Japanese are more focusing on hybrid vehicles, fuel cell vehicles, and they are also doing lot of research on your petrol vehicles. Last year they launched Alto, Maruti Alto, what we have here, that gives 37 kilometers per liter. That is kind of a lean fuel. They have developed a fuel injection system by which it gives you so much high mileage. So because gasoline vehicles are not going to disappear overnight, it will go in a phased manner. So Japanese are totally working in a different way, but Koreans are definitely working on the conventional electric vehicles. So we will see these 4 areas and understand the various applications. When supercapacitors can be used, application that requires high reliability backup power, short-term breach power 1 to 60 seconds for transfer to secondary source, or a orderly shutdown. See, for example, a lift in your housing complex. If there is a failure, the lift immediately stop wherever it is, and there is a panic in the lift. Sometimes emergency lift it doesn't work, and there is totally dark. Now, if you use this ultra capacitor backup, supercapacitor backup, it will go to the nearby floor. It will sense at what distance from lower or upper floor it is, and accordingly it will give power to the traction motors, momentary power for 5 seconds, and within 5 seconds or 10 seconds, depending upon the energy that you are going to provide, it goes. This is one of the fantastic application of supercapacitors being developed by one Bhopal-based company, and they are marketing it now with most of the housing complex. Because maintenance of batteries is a big headache for society people. Power quality right through a compensate for momentary surge. Because if you see the grid, there are a lot of sags and surges that takes place. Especially you might have observed when there is a welding happening, your lights become dim. So to avoid that grid unbalance, supercapacitors are used in the grid system. So it reduces the power demand, momentary power demand, and you can have a lower capacity grid. Power for large momentary in rush or power surges. So this is a same application. So if you see energy storage, primarily energy source. So if you compare, then we can go either for continuous power usage or peak power demand. Accordingly, we have to select the application and select the capacitor for that. For example, fish storage system in windmill. Now this is in a great demand for every windmill. Say a 1 megawatt windmill requires around 72 lead acid batteries for each blade, 12 volt, 7.5 amperes. They are all connected in series. Why? In case there is a failure of grid, because initially when they crank windmill, they need external power, and pitch needs to be aligned according to the wind speed. And whenever they want to have it stop for maintenance or some other problem solving, they have to pitch out the windmill so that no the air will affect its rotation. In case of storm, you have to be very careful adjusting the pitch of each blade, and it has happened so in past that many windmills have collapsed due to the storm. They were not pitched out, or pitched out system went away. So here the maintenance of battery is an headache. So most of the windmill manufacturers now have come out with a model using supercapacitor. It's a 75 volt 81 farad module for every blade, and most of the problems are resolved because of the application of supercapacitors, because pitch control requirements are for very few minutes. And again in forklift is equipped with a fuel cell, and cell system is an ultra capacitor. So most of the forklifts, they have ultra cap module of 112 volt 55 farad. So it gives 40 kilowatt peak power, momentary power, because when you want to lift something, the forklift requires very heavy inrush current, and that is supported by the supercapacitors. Even the Toyota Supra high voltage hybrid racing car uses supercapacitors along with the IC engine. It's a hybrid system, and it can have the 480 bhp at 6,880 rpm. So it uses a supercapacitor bank. If you see the module here, there is a supercapacitor bank here, and which gives the momentary power required for accelerating the racing car, because acceleration must be at peak as far as the racing car is concerned for winning the race. So it has given excellent result for 24-hour endurance test at Kotachi, Japan. This is another interesting application which is happening and very old now in China. Around 8 to 9 years back, they introduced this solution. They have a bus totally on supercapacitors, and there is a pantograph above the bus. The bus comes to the bus stop, pantograph goes up, supercapacitors are charged. Okay, meantime passengers get in and get out. Okay, and the bus goes for next destination. The charge is so much because that those capacitors are charged within a minute. It can take you 5 kilometers. So next bus stop is definitely less than 5 kilometers. Again, same process is repeated. Bus stops, passengers get in, get out, pantograph goes up and charges the supercapacitor. So there is a fleet of buses, 41-seater buses are operational in China. PSL vehicle also gaining popularity, and they are popular in Tongji University and Shanghai, China. They have developed 24 kilowatt fuel cell, and a project group provided 20 fuel cells for 2008 Olympic game. So this was the car developed during the Olympics. This is another bus they have developed, 8 to 10 minutes of pull up, giving range of 500 kilometers. So 8 to 10 minutes charge can give you 500 kilometers. That's the beauty of this design. Fuel cell buses deployed to take visitors to Winter Olympics in 2010 in Vancouver. So this is the block diagram of the bus which was developed, and they are still running. The first hybrid powered train is developed by China, and it has got the supercapacitors inside. Though it is not a train, it is a tram, and the train will take 3 minutes to refuel, that is discharge, and will have 100 kilometers range. The main benefit for cities, that will be cleaner air and reduce operation cost. The only emission will be water. So because of this hydrogen, the from silencer only the water comes out, so no pollution. This was deployed in 2015. Let me see why it is not moving. A minute, it is not moving. We will have question answer session at the end of my presentation. It is just, and hold on for a minute.
Okay, sir.
Yeah. 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 Now this is another car, fuel cell vehicle, FCVs. Of course, though I am telling you it is a hydrogen power car, but so there is an application of supercapacitors for inrush current. Yeah. Emissions are of course very low, and it is an environment friendly car. Now we will learn about the traction energy. We were discussing about the suburban train, local suburban train which are in Mumbai. So when a train comes to the railway station and another station starts, there is a heavy load on the grid, because when the train starts, it requires very high inrush current. So a supercapacitor based energy system is installed in Germany. Please watch this animation very carefully. Now the train is coming in the railway station, and which is halting. Brakes are applied. So brakes are dynamic brakes, not conventional brakes which convert energy into heat, but it convert energy into electricity, and that is stored. See, now this has come. Energy is stored in the capacitor. We will watch it again. The train is coming to the station. Brake energy is getting stored into the capacitor. At the same time, there is another train waiting to start. All this stored energy will be now utilized for initial inrush current of the train. So grid balancing, because otherwise you will need a grid with a heavy power capacity or power capability, which can be reduced because there is a buffer energy stock available at every railway station. So a braking energy is a dynamic braking, and that is converted into electricity, which is charged into the supercapacitor module, and it is discharged when the second train leaves for the station. So if we apply this in Mumbai suburban railway, a lot of grid wastage can be saved, because grid balancing will happen and need for peak power will go down drastically. So this is the energy saving by 30%. In this system, there are 1344 cells of 2600 farad each, and 13 sold by Siemens in 2008. And payback is just 4 years. So this is gaining popularity, especially in European countries. This is also voltage dip compensation. We said there are sags and surges on the main grid, and you can see sometimes our lights dimming or getting bright. So this supercapacitor system made by Maiden can take care, and each module have got 130 farad, and grid voltage is 625 volt. So this is also another popular system in Europe for grid balancing. Ultra battery is another concept which has already come in the market, and it's a combination of lead acid battery and supercapacitors. And the life of this battery is quite high because of the supercapacitors. They take care of the initial unloading of energy. That's why, though it is 500 charge discharge cycle, it can practically double its life, because the batteries are not loaded to full discharge because of the supercapacitors. Impedance of the supercapacitors is lower than battery, so when you connect for a cranking operation, the supercapacitors get discharged faster. I was director for business development in one of the two-wheeler automotive industry. That time I introduced this hybrid battery for cranking of Honda Activa. It was a supercapacitor unit and VRLA battery. As I mentioned in my presentation earlier, that you don't need such a big battery for running Honda Activa. It is required more for the cranking. So we thought that why not introduce supercapacitors for cranking and just put a small VRLA battery for charging it and rest of the electronic that is used in two-wheeler. So we have just used 2.3 ampere hour battery with supercapacitor bank. Okay, so this is a block diagram. If you see the construction, there is a VRLA battery below and a supercapacitors. 6 and 12 supercapacitors are connected in series parallel. On the right hand side, that unit you see is a manufactured for Honda kickstart vehicle. That doesn't need any battery. So this is a combination of only supercapacitors. This also we sold around 25,000 units when we were manufacturing it. And this battery I sold around 15,000 in the market. This was for the trial in open market and they outperformed. And life that we gain optimum was 6 years. Normally after 2 or 3 years, you have to replace your Honda Activa battery. And in that case, only you have to replace this. Today battery cost is around 1200 rupees and this small battery costs 300 rupees. So your recurring cost for two-wheeler battery maintenance is just 300 rupees after 2 or 3 years, depending upon your use. So this is a comparison and we have really found and customers also really found this. But we were integrators. We were neither manufacturing VRLA batteries nor supercapacitors. And once there was a bad lot from Samoa and we have really badly hit by the market, but the quality of the supercapacitor was very poor. And same time we also got a problem from a battery, VRLA battery. So we could not survive for a long because of this issue. But unfortunately, we were not capable of manufacturing either supercapacitors or batteries. But if still someone comes out with a good quality capacitor, because this we did around 7-8 years back. Now things have changed. Rather, we were too early. But I have 15,000 customers who are happy and they still demand this battery. But most unfortunate, we could not get the right kind of quality capacitors and quality battery. Ultra capacitors are also used in UPS for a shorter duration. Whenever you need a power just to take care of your data and you want to store. Like earlier, when the computers were launched, there was a small UPS which used to give 15 minutes backup. So nowadays, backup required maybe 5 minutes or 10 minutes, especially access control when you want to enter certain room and there is electricity failure. You can always use supercapacitors for operation of the solenoid. Solar energy applications is one area where now supercapacitors have started. Because shadowing clouds is a problem. Or rainy days, your solar panel cannot generate electricity. So you need to have grid balancing. And inverters increase peak power reverse, which leads to increased cost. So to have the best trade-off, you can use the supercapacitors in the whole system. So during the sunny time, they will be charged, and whenever there will be a shadowing clouds, it can take care of that demand. Of course, it should be demand should be defined properly, and accordingly, supercapacitors must be employed. Otherwise, cost will be too high and exorbitant. So you have to have the best trade-off of number of supercapacitors that you can use for your load variation. So this is a new era in the solar system which is increasing. This can reduce the battery size up to 15% and can reduce the battery replacement and maintenance costs significantly. LED lighting is another area where now supercapacitors are being used. Rather, supercapacitor based batteries are also the emergency lights are available. One was produced by my company under Science and Technology Park, Pune University, and we sold, we rather distributed more than 15,000 lamps in Adivasi area, wherever there was nothing for learning and studying for the Adivasi children. So they are very popular, and there is no battery, lead acid battery. So no maintenance and lifelong. We can predict the life of that emergency lamp 10 to 15 years. This is that lamp we introduced for the villagers. They use only supercapacitors and small solar panel can charge the super cap inside this emergency light. Also pacemaker application. So pacemaker battery, when it dies down, you have to replace, rather operate the patient and replace the battery. Instead, you can have a supercapacitor inside, and you can have a inductive coil around, and just take the inductive coil, and through transformation you can charge the supercapacitors in human being. So even if the patient has to go every year for charging the battery of his medical application, it is possible and it is cost effective and it can avoid operation. Hold on, something went wrong. Another application we did recently last year for military operation, because you know when we have outpost, military outpost, they have to carry their radio, high frequency radio, for keeping contact with the headquarters. And carrying heavy battery is you need another person to carry batteries, one person to carry the equipment and another person to communicate. Instead, one man can manage whole thing. What we have developed, a supercapacitor based switchboard power supply. The supercapacitor's most important application in radio will be use SMPS, making portable and lightweight. So transceivers, military transceivers specifically operate on 25% in single sideband mode and 35% duty cycle in Morse code mode. So during duty cycle, the concept of this was the concept followed in the design. So if you see, 50% is the supercapacitors, bank of supercapacitors. There are about 50 farad, 2.7 into 25 supercapacitors, which make their bank at 28.5 farad and 18.9 volt. Voltage balancing with is done with using 2.7K resistor. This is a small VRLA battery of 7.5 ampere hour, and this is a standard SMPS. So this can give peak current demand at 12 volt up to 25 amps. Okay. Otherwise, you need a very heavy battery, 32 ampere hour battery for that. And the manpack trials that we conducted, the guy at the border is very happy to receive such a portable power supply. So this was our trial on transceiver of military. Now let's touch upon some of the commercial inputs, because those who want to make career in supercapacitor and its application, this is the right time and very good opportunity. In 2010, the worldwide sales of supercapacitor were around $400 million US. Current year, it is estimated at 1.1 billion. As per the market research companies like POMOC, Frost and Sullivan, Nano Market in 2012, the supercapacitor market can grow up to 2.2 to 3.5 billion by 2020, which has already touched. Because of the COVID, it might have affected. Provided, of course, it has got if and buts. The thrust on green energy application remains forceful. Price and performance ratio of supercapacitor improves by 200%, which is happening because every year the price is reducing and performance is improving. Performance means the tan delta losses are getting reduced in the design. Market spread in USA 43 to 50% and Europe 26%. So return, so ROW will be 24 to 30%. Now, as far as Indian market is concerned, it will reach about 10.7 million US dollar by 2020. That is this year. And main market segments in India are automotive, of course, EV, because of the government policy, because 5 to 7 million EVs are supposed to come on the road by 2024. Solar and wind, railways and metros, grid integration, consumer and defense. These are the areas where the applications are going. Defense, there is a tremendous application of supercapacitors. The nuclear submarine, if you want to start, the supercapacitors are used for giving the pulse. Even in the military vehicle, for Bofors or other guns mounted on the trailer, if the power supply gets disconnected, the elevation and azimuth of the gun can be controlled using supercapacitors. Constraints for worldwide spread and use of capacitors. So this is also very important input. We have to designer has to keep in mind it has got a low energy density. We explain and discuss on this. Voltage balancing is required in application, so another tedious issue. Of course, passive active balancing gives you very good relief in this. Complex power electronic interface, circuitry required for interface. Expensive research, because so far the research is funded by government, US government and some private companies, but it is very expensive. So in India today, the research is only government agencies are able to do it. No private partner or participant. There's one Pune-based company trying to develop the supercapacitor indigenously. But at the same time, government spending so much money, you know the speed of our government research. So it's very slow. So you can't expect any outcome so fast. It has got high cost through declining year on year. They're declining year on year, but today they're high cost. Limited application wherein can substitute primary energy source. Green and renewable energy solutions still capital intensive, no trust, because they're still expensive. Solar energy, the initial investments are very high. So what will be the future energy storages like in automotive? So with different technologies under various stages of developments, energy storage devices will serve an array of functions, care of both long-term as well as short-term needs of power systems. There will be improved stability and reliability of existing systems and ensure their optimum use. Renewable energy sources will get a big boost with these devices, as there will be make a real scale energy storage possible. So this is now I can say it is possible. Power may then be generated when available and energy stored for later use when required. So this is another beauty of supercapacitors. This will also add to a system security in case of emergencies. Thank you friends for patient listening. Now I keep open the floor for question and answer.
Hello participants, if you have any questions, please ask. Participants, if you have any questions, please ask.
Yeah, questions are welcome. But normally I do this session with hands-on. I bring some applications and the other participant assemble it on motorcycle. That is the fastest exercise I can take.
So if nobody is having question, shall we conclude the session?
Yeah, please shoot out your questions. Whether I made it too simple or it was too boring.